So, as we explained, today's webinar is about the topic Expert's Guide to the World of Anchors. So, before we start, my name is Tino Thomas. I am Technical Manager for UAE in Fisher. Today, for the webinar, I would be using the ID Fisher MEA for any. Also, you would have my colleagues who would also be there to assist you if you have any technical problems. So far, is the audio clear? Is the sound and is the video, everything is clear? Do you face any trouble? Okay, if you face any trouble, my colleagues would definitely get in touch with you and they would solve the issues. I am working with Fisher from 2012, so it's around 7 years, more than 7 years now with Fisher. We would go to the time split. So today's webinar total would be 1 hour. The webinar itself would be 45 minutes from 11 a.m. till 11:45. Then we would take time 10 minutes to answer all your questions and answers. And then we would go to the poll to get a feedback about the session. For your better experience, please use Google Chrome or Firefox. Do not try not to use Internet Explorer because you might have some technical problems. And please, your internet speed is very important. So please try to avoid any parallel downloads. We want to answer all your questions and it would be answered towards the end. I would explain where to post questions so your questions are never lost. And all the correct answers would be emailed to you at the end of the webinar. So I assume this is a screen what you would be having. So here you have chat window where you can chat with us one-on-one. Any issues you have or any trouble you have, you can mention in the chat window. But if you have any questions, technical questions, please go to the questions tab and then post your question there, because in chat window, maybe there are a lot of chats happening and it might get lost. So please, we don't want to lose any of your questions. Go to the questions tab and post your question there. Is it clear? So this is where you have the chat window and this is where you have questions tab. It's always better to make it full screen and the full screen logo is here. So all your questions which is there in the questions tab, we would answer it before the end of the session. I hope we can answer it within 10 minutes. If we have more, do not worry. We would personally get in touch with you and let you know what is the reply. And also, last but not least, this is a service which we are offering to share the knowledge with you guys. So we want it to be more effective. So if you feel that there are some area of improvement, please go to the poll screen and rate your experience of this webinar. So this we are using to improve our webinar services. Very important for us. So please do not leave the session before giving us a poll rating. That's it. We are starting the session now. A brief introduction about Fisher. Fisher, we are present in more than 100 countries. And wherever you go to the construction field, you would see Fisher presence in any of these countries. We are operating through around 47 subsidiaries. And on your left side, you can see the flags of several countries. These are where Fisher products are directly produced by Fisher. And then we have different divisions. Fisher Innovative Solutions of Fixing Systems is where I come from, is where we operate the webinar. It is all about fixings, anchors, supports, and so on. We also have a different division, which some of you might not be aware. We are pioneers in automotive industry as well. We manufacture main internal components for major automobile brands like Bentley, BMW, Mercedes, and so on. Also, we have a very interesting division. It is called Fisher Technique. I personally love this division because these are smart, innovative toys for kids. And then Fisher believe in lean process management by cutting down waste to operate more efficiently. So Fisher, we have an in-house consulting division, which is called Fisher Consulting. And then we also acquired automation division, which is basically into touch screens and uh, capacitors and these things, LCD screens and so on, which is also part of our world. Okay, now you want to be an expert in the field of anchors. That's why you attend the webinar, I guess. So let me ask, what is an anchor in your understanding? What do you think is an anchor? Okay, let me give you some options. Is it option A or is it option B? What, in your opinion, is an anchor? Option A or option B? Okay, so you feel it's option A. Great, good. Okay, some of them says it's option B. Okay, very good. Thank you, Mr. Michael. Thank you for Mohammed. Thank you, Hani, for being active participation. Some of you said A, some of you said B, some of you said both. So all of you are right. Both of these are anchors. One is used to anchor a ship, the other one to fix something on concrete. So as you guessed, we are going to limit ourselves to option B. And option B means anchor bolts, which are used mainly to connect structural, non-structural elements to concrete, masonry, boards, etc. So thank you very much for being the sport, being actively participating. Also, type of anchors. If you see the history of anchors, the first type of anchors which was invented or been used in construction field is this type of anchors. Any idea what it is called? Okay, it is popularly known as cast-in anchors, which are mainly casted before pouring of concrete, and then you have to wait for the concrete to completely cure and then apply the load. And then there is another type of anchor called anchor channels, wherein a channel with a bolt is embedded before casting of concrete, and then with the help of T-bolt, your base plate is getting fixed. And then the latest innovation in fixings are post-installed anchors, wherein you have to wait for the concrete to completely cure. You can drill a hole wherever you want and fix a post-installed anchor, which can take superior load, almost the same like the previous methods. Now, what in your knowledge or experience does Fisher supply? Is it cast-in anchors? Is it cast-in channels? Or is it post-installed anchors? What is your feeling? What is your understanding? Okay, nice. Okay, post-installed, post-installed. So most of you believe it is post-installed anchors. Okay, you're absolutely right. But just to inform you, right now we have cast-in channels as well added to our range. And of course, we are pioneers in post-install anchors. Thank you very much for actively participating again. So in post-install anchors, there are only three type of anchors. One is expansion anchors, wherein the anchor expands, putting some friction in between the anchor itself and the concrete, as you can see here. There are different types. We have countless number of anchors in this mechanism. Then you have a second type called resin bonded anchors. Also different locations, different names, but popularly it is resin anchors or chemical anchors, which is a more common name. So here we use a magic solution called chemical anchor to form a bond. It is same like gluing principle. It glues between the rod and the concrete. So this is one method. The third method, any guess? What could be the third method which we use for anchoring? Okay, let me introduce. It is called undercut anchors. Undercut anchors also use uh, the same method of drilling like expansion anchors, But as you can see in the top picture, you make a bigger hole towards the end of the hole. So here it is locking. The anchor cannot come out because it is locking. So it is also known as locking principle. Right. Okay, Mr. Imad, let me go back. He says it is with sleeve. Okay, sleeve anchors also work on expansion principle. There are some sleeve anchors which work on undercut principle as well, as you can see. So yes, you're right partially. Now here's a fun quiz. Who founded the first nylon plug? I'm sure you have seen this in construction site, or at least you have used it in your home to fix some curtain, to fix some photo frames. So who do you think is the first inventor of such a product? Any idea? Okay, nice. Okay, you're right. Mr. Professor Arthur Fisher is the inventor of nylon plug. Imad Al Sahi, you're the first to answer it. And yes, thank you very much. So he invented this product, and which is why it is popularly known everywhere in the market as Fisher plug. Okay, now there are main factors affecting the anchor performance, which is very important for you to understand. So the first factor is the base material. Where are you going to install your anchor? Is it a concrete wall? Is it a masonry wall? Is it a gypsum board? And so on. Also, what is the drill method which is supposed to be used? If you don't know the drill method, you can use a wrong drill method which affects the anchor capacity. Very important. And then load direction. Do you have tension? Do you have shear? Do you have combination? Do you have moment? And so on. And then load type. Do you have a static load, seismic load, dynamic load, etc.? And then third, how is your arrangement of anchors? Do you have 2 anchors, 3 anchors, 5 anchors? What is the spacing between them? Do you have an edge distance? And so on. So don't worry, we will go into each one of these aspects and let's learn together. First thing in anchor selection, mainly we have 3 main base materials: concrete, masonry, and board elements. And based on our experience in a construction site, mostly fixings are in concrete, which is around 60% fixings goes to concrete. There is around 25 to 30% in masonry, and then around 15 to 20% in board elements. So let's go one by one. In concrete, you have normal concrete, which is used, RCC structures, which is used everywhere. There is also lightweight concrete, which is used mainly for non-structural elements like lintel beams or partitions. And we cannot go through concrete without using the term crack concrete. Any idea what is crack concrete? I'm sure you're an expert, so you would definitely know what is crack concrete. Okay, good. So when we say crack concrete, we are referring to concrete which is subject to tension. So as we know, concrete is very good in compression, but it is weak in tension. So it has only 10% of its compressive capacity in tension. Thank you, Mr. Imad Al Salahi. Yes, you are very well right. Whenever you have a concrete under tension, or the tension side of concrete is termed as crack concrete. To make it more simple, to make it more clear, let's watch a video. So here we have a video where you have a ball. Can you see the video? Right? Okay, don't worry if you do see a picture, because I've not played the video. You have a ball which represents a load, and then you have a concrete structure. So let me play the video and see what is the effect of the ball moving on top of the structure. Right. Let me play it once again. Pause. Now you can see the ball is located in the middle of 2 at the center of the beam. So you can see black lines in the bottom side of the slab or the beam, and you can also see black lines at certain other places. So this shows tension, stress acting in the concrete at these particular locations. So whenever you have tension acting on concretes, we call it by the term crack concrete, and it is very important that you choose fixings approved for crack concrete. If you choose a wrong fixing in crack concrete, it can be a fatal accident because you would result in up to 80% capacity of anchors if you use an anchor which is not approved for crack concrete at this particular location. So let's say if you have an anchor approved for use in crack concrete, you're using in non-crack concrete, there is a difference of around 30%. This is, I'm again repeating, this is a comparison when you have an anchor approved for both cracked and non-cracked. So there is a difference. If you use this anchor in uncracked concrete, let's say you get a capacity of 10 kilonewton. Same anchor, you take it, you use it in cracked concrete, you would result in a capacity of only 7 to 8 kilonewton. So around 30% reduction is possible when you consider cracked concrete in your designs. If you use by mistake an uncracked concrete in cracked concrete, the difference is not 30%, it would have a drop up to 80%. So this is again important point which I would like to highlight. Never use a non-approved anchor in cracked concrete. Very important. This is a safety risk. It could be a threat to life or to property. Either be the case, please make sure that use only approved fixings for cracked concrete. And then that was about concrete. Now the second most important base material is masonry. So in masonry, you can see different elements like solid bricks or solid concrete blocks. You have also perforated materials like hollow blocks. You have solid blocks with porous structure. This is also very popular in Middle East because of high temperature and more energy saving. It is called aerated blocks or AAC blocks, which is also very popular in the market at the moment. Also, the last base material type is called board elements, which is also called as thin walled materials, which is primarily used for partition, for ceilings, etc. Examples are gypsum, gypsum boards, ply boards, cement boards, etc. The trick to fixing in a thin walled material is to use locking principle because friction or chemical anchor possibly is not an option. So as we discussed earlier, drilling method is very important in the performance of an anchor. If you have a strong base material like concrete, you can go with a strong drilling method called hammer drilling. If you have a medium strength base material, you can go with a drilling method called impact drilling, wherein it is very similar to hammer drilling, but the force of hammering action is less. And then if you have a very weak base material like some of the soft blocks like AAC block, for example, you have to use only rotary drilling. There is no hammer action on the drill bit. Is it clear, the drilling method? By the way, so far if you have any questions, please go to the questions tab and post a question so we can reply to all your questions there. Now here's a fun fact. Have you all heard of Thomas Alva Edison? The man who made more number of inventions when we were studying in school? Okay. Professor Arthur Fisher was mainly an inventor. He was not an entrepreneur, he was an inventor, and he has more patents than Mr. Edison. And to be precise, he has around 1100 patents to his name. And then, did you know that he also invented the flashlight? The modern flashlight which we use in our camera, in our mobile phones, was patented by Professor Arthur Fisher. Guys, also a small reminder, if you have any questions, please go to the questions tab and don't post it in the chat window because as we are chatting, the questions might get lost. Uh, we have a question now by Mr. Abdul Razak regarding the maximum strength of concrete. Thank you, Mr. Abdul Razak, for posting this question. The maximum compressive strength of concrete approved by Anchor as per the code is C50/60, wherein the cube strength of concrete is 60 Newton per mm square. But as you know, in modern construction, you can have higher grades of concrete. So we have test reports of anchors to be used in higher grades of concrete up to C90 or C95. So this is a picture of the flashlight invented by Professor Arthur Fischer. This was the first flashlight which was synchronized with the camera, and then development happened, and now we have flashlight even in our pockets in the form of mobile phones. Stresses or load directions for an anchor. The anchor can be subjected to a tensile load, a shear load, or a combination of tension, shear, and then bending moment. You might ask a question, what about bending moment or torsion? So when you have moment or torsion, it is converted to shear or tension into the anchor, and then it is calculated as tension force or shear force. So these are the possible 4 combinations or load directions which an anchor can be subjected to. Now regarding the load types, you can have a static load on an anchor, dynamic load on an anchor, and then shock load on an anchor. Static load is very simple. As you can see from the picture, you are fixing a balcony handrail or a balcony itself. It is the same load throughout the lifetime of the anchor or the structure. The load does not change. Whereas a dynamic load is a moving load. There is a certain series or pattern which the load is following, like up and down. Let's say fixing of an elevator shaft, or fixing of a robot, let's say, or a production machine. So all these are classified as dynamic loads. And what is a shock load? What, in your opinion, is a shock load? Any idea? Any guess? Okay, shock loads are loads which acts in a very high magnitude for a very small period of time. So examples of shock load would be a seismic activity or an earthquake. It could be a bomb blast. It could be a fire accident, and so on. You don't anticipate this load to be active throughout the lifetime of the building, but maybe there's a huge load acting for a few minutes and then it goes back. So this is called shock loads. Now, to anchor and its resistance, it is very important to know the arrangement of anchors. For example, in this example, I have 2 anchors. So it's very important that we know the spacing between the anchor and what is the distance from the anchor to the edge of concrete. Also, it's very important to know what is the member thickness. For example, are you fixing on top of a slab, and what is the slab thickness? Is it 100 mm, 200 mm, 300 mm or more? So this is very important. It could also affect the anchor performance, because you have more depth, maybe we can have more embedment depth. If you have less depth, you have to select an anchor with shallow embedment depth, and so on. Also, the more deeper you go, it has an influence on the concrete capacity, which we would also cover in the coming slides. Now, from here on, we have a term called S, which is denoting the spacing between 2 anchors, center to center spacing. And then C is used for edge distance. So this is from the center of the anchor to the edge of concrete. And also remember this particular term, it is called H effective. It is the embedment depth of the anchor. So it is the depth from which the anchor starts taking the load. So these parameters are very important when we go further down into calculations and so on. So to prove any anchor is safe or unsafe, we have to do a couple of checks. Let's go one by one on proof for tension. So here in tension, we have to check if the concrete itself is strong enough to take the load, which is normally called as concrete cone failure. We also have splitting failure. We need to know that based on this load, the concrete does not crack or split. We have to know if the anchor body, which is made of normally steel, can take this load or it would break. And then we would also need to check, are we applying more load than the anchor mechanism is designed for, right? So let's go to the first failure mode, which is concrete cone capacity. So when the anchor is subjected to a tensile force, it distributes the load inside concrete in a cone shape, as you can see. The typical dimension of this cone is a radius of 1.5 times embedment depth. So when you have two anchors, the spacing between them has to be 3 times the embedment depth. Is it clear? Okay, so when you have, let's take an example. Imagine you have an anchor with an embedment depth of 100 mm. What shall be the spacing between two anchors so that you can get maximum concrete capacity? 100 mm embedment depth. What shall be the okay. Okay. Mohammed has first replied as 300. Yes, you're absolutely right. 300 mm. So I'm sure you are catching the points very well. But do you think 300 mm spacing is always possible at site? Do you think there will be limitations? Absolutely, you're right. There will be a lot of limitations, and you possibly cannot go with 300 mm or 3 times embedment depth always at site. I agree and I understand 100%. So you would have condition like this where the cones are overlapping. So what we do is, when we have this overlap, you have to reduce the capacity of anchors. Let's say capacity of one anchor, cone capacity is 10 kilonewton. When you have two anchors with less than 300 mm spacing, you would not have 20 kilonewton capacity, maybe you have less. So this we have to calculate, and then we can judge, is it safe or not safe. But what happens normally in offices is that they take the capacity from the catalog for one anchor, and whatever be the spacing, they multiply with the number of anchors, which is absolutely wrong. So it is a safety factor, safety relevant aspects. So please make sure that you have to, if you are reducing more than 3 times the embedment depth, you have to cross check. The initial value of the characteristic resistance. Now to make it simple, I won't go through calculation of how to calculate when you have 10 anchors, how to calculate the total concrete capacity. No, let's keep it simple. Let's calculate how to know the capacity of concrete when you have one single anchor in a big slab. So let's take an example. So in this example, you have an anchor embedded at HEF. You know the dimensions of the cone. The radius is 1.5 times HEF. The formula to calculate the single anchor concrete cone capacity is K1 multiplied by cube strength of concrete, square root of cube strength of concrete. Then you multiply it with embedment depth to the power of 1.5. So K1 is 7.2 if you have cracked concrete and 10.1 if you have non-cracked concrete. If you recall my previous slide, I said that you have a drop of 30% from non-cracked concrete to cracked concrete. Now, can you see where this 30% is coming from? From 7.2 to 10.1, there is around 30% gap. So this is why we always say in cracked concrete, you have a reduction of 30% capacity. So is it clear how to calculate the capacity of concrete cone for single anchor? So it's K1, which is K1 depends on cracked or non-cracked, and these are the values. And then cube strength of concrete is your compressive strength of concrete. And then HEF is the embedment depth to the power of 1.5. So is it clear on how to calculate the capacity of a single cone? Okay. Can we do a small exercise? Okay, sure. So we have a concrete, we have an anchor. It's an M10 anchor, which is embedded at 100 mm. Compressive strength in cube is 40 Newton per mm square. It is cracked concrete. What shall be the concrete capacity after dividing it by a safety factor of 1.5? Is the question clear? Okay, no problem, Mr. John. Here's the formula. Here's the formula. We have cube strength of 40. We have embedment depth of 100 mm, and it is cracked concrete. So you know every factors in this formula. You just need to put it in this expression and you would get a result. And please, this is characteristic value, which means it is the actual failure value. You have to use a safety factor of 1.5 from this. Okay, Mr. Imad, I'm really impressed. Quickly, you found out, you came up with the answer. It is around 30.4 or precisely 30.3 something, as you rightly said. Thank you very much for trying and working parallelly at the same time. Now we would know how to calculate the pull-out capacity of anchors. I'm sure you know how to calculate the steel capacity because it is just the grade of steel, which is the yield stress of steel multiplied by area, which is very simple. But when you have pull-out capacity, you have two scenarios. Either you have a mechanical anchor or an expansion bolt. Then it's pretty simple. You can take the pullout value directly from the approval document of this value. In ACI, ICC document or European Technical Approval document, you would find directly the pullout value. So let's take an example of an M8 anchor with an embedment depth of 45 mm. In the approval, it would be directly mentioned as 4.6 kilonewton. So it's pretty straightforward. You have to divide this 4.6 with safety factor mentioned in the approval. So let's say if you have 4.6 and the safety factor mentioned is 1.5, then 4.6 divided by 1.5, you would get something like 3.03 kilonewton. When you have chemical anchor, it gets little more tedious. You have to calculate the capacity. So still, if you open the ETA approval of the chemical anchor, you would see a factor called the bond strength, which is normally given by the denomination of tau. So here, let's say, take an example. So here we have, let's say, 12 mm anchor. The bond strength or tau value is 15. We take this value and substitute in this formula. It is pi into d, which is diameter, multiplied by embedment depth. How deep is your anchor embedded? Multiplied by the bond strength. So what you get from the ETA approval is normally the bond strength. Okay, great. Now, example. Before I start with, normally in the approval document, the capacity which is mentioned would be for C20/25 grade of concrete. If you have more stronger grade of concrete, there is an increase factor which is also mentioned in the ETA approval document. In this example, I want to calculate the pull-out capacity of an M10 threaded rod installed using Fischer FIS EM Plus at an embedment depth of 100 mm. So now we have this is the bond strength. So we are considering temperature range 1. So in temperature range 1, we have a bond strength of 15. The formula is given here. Can you calculate and tell me what is the capacity in terms of pullout? The embedment depth is 100 mm. Great. Thank you, Mr. Sagar and Mr. Singh for participating. Yes, it is right. It is 47.1 kilonewton. Again, this is a failure load, which means at this load, the anchor will come out. You have to apply a safety factor, which is also published in the ETA. Now, as you rightly said, the failure capacity in pullout is 47.1. Let's say this particular anchor has got a safety factor of 1.5. What is the design pullout capacity? Great, Mr. Imad, you're a genius. Yes, it is around 31.14. Mr. Singh, thank you very much. Right. No problem. Thank you. Thank you for being actively participating in this formulas and calculations. That was about tension. In shear also you have to do certain checks. So in shear, again you have steel failure, you have pry-out failure, and you have edge failure. So here in steel failure, normally it is directly half of tensile steel capacity. And here is an important thing. When you have shear load with lever arm, which means your base plate is away from the concrete, it has grout or there is an offset, then you have to calculate the lever arm capacity of the anchor. The MRKS value is given in the ETA approval, and length is the offset distance plus half diameter. This is simple. It is just to calculate steel failure. Then you have concrete pry-out capacity. This is the failure of concrete in shear direction. So in concrete pry-out, it is directly linked to the concrete cone capacity of the anchor. So K multiplied by NRKC. So K is 1.7 for crack concrete or 2.4 for non-crack concrete. So from our previous exercise, we know that the concrete capacity is 30 kilonewton. What shall be the shear capacity? Imagining it is crack concrete. Sorry. It is K1 multiplied by NRKC. No, I am asking about concrete pry-out failure. So pry-out failure is K1 multiplied by the concrete capacity in tension, which was 30 kilonewton. So you need to multiply 1.7 into 30. Yes. Thank you, Engineer Lovely. It is 51 kilonewton. Yes. Thank you, Mr. John. This is 51 kilonewton. Sorry. Also for concrete edge failure, there is a complex formula which you can calculate. But before we go to any formula, it's very important to understand what happens in an edge. So let's go to the actual scenario. In terms of tension, the area is calculated from the top because we were speaking about diameter of the cone. In terms of shear load, the area is the cross-section area, which is happening here because the shear direction is perpendicular to the anchor. So let me ask you a question. What is the advantage if I make two holes near the edge, slotted holes? I have 4 anchors, and the base plate carrying 4 anchors is subjected to a huge tensile force. So if I make 2 anchors near to the edge as slotted holes, okay, Mr. Imam had said that you can increase the edge distance. Yes. In this case, what we are doing is these 2 anchors will not take any shear load. So the shear load would be completely taken by anchors away from the edge. So here you are improving the edge distance. Also, another tip is when you have anchors arranged parallel to the edge, you have a wider cone, whereas you have anchors perpendicular to the edge, you have a narrow cone. Yes, Mr. Michael, thank you very much. You are also absolutely correct. You can eliminate shear load on the 2 anchors near to the edge. So is the concept of edge clear? Okay. Now we know how to calculate tension. We know how to calculate shear. We have to calculate a very important aspect, which is combination. So we know the tension capacity. So NSD is the load and NRD is the capacity. This is the design capacity and NSD is the design load. So we divide load by capacity, we get beta N, which is the utilization in tension. Same thing we do for shear. So we divide the shear load by the shear capacity, you get utilization in shear, which is beta V. What we need to do is we need to find combination. So we add the two combinations. It should be less than 1.2, or beta n to the power of 1.5 plus beta v to the power of 1.5 should be less than 1. Only if the tensile utilization, the shear utilization, and the combination, only if all three are passing, then you get a safe result. So any questions so far? Please go to the questions tab, post your questions. We will discuss these questions right now. So this is the time. We are almost on time. We are 11:44 now. So this is the end of the presentation, but now we would go through all your questions which you have posted, and then we would see and we would reply to all of those questions. It is a very successful day for me. There's around 65 active participants. It is not just participants, it is all you were really active, you were participating, and this is very important for us. Okay. Mr. Andrew had posted a question. Can you be so kind to answer why? I cannot see the full question. Just give me a moment. Okay. Can you be so kind to answer why I am typing messages? My name goes to the chat, not correct. My registered name is Andrew Rasiko from Uzbekistan. Okay. My colleague would check into this topic and he would get back to you on this. Mr. Sagar, what type of drilling method used in case of undercut anchors? So normally in undercut anchors, we have to have a special drill method. Depends on the type of anchors. Normally the manufacturer of undercut anchors, they would also supply you with drill bits and setting tools. So you are supposed to use only this particular method. Wherein there are some kind of undercut anchors which does not require normally any undercut anchor you have to use the proprietary drill bit and setting tool. This is mandatory. There are some locking mechanism anchors like concrete screw which does not require any particular special drill bit. You can use the standard hammer drill bit, but if you're using undercut anchor in specific, you have to use only drill bit and setting tool by the same manufacturer, which is very important. Can you please elaborate what are the precautions to be taken before choosing type of anchors for AAC? This is a question, a good question by Mr. Suresh Yalla. So Suresh, the main precaution what you have to take is to understand the fact that AAC block is a weak base material. So you must always understand, or we must understand, that AAC block cannot take the same load like a solid block or a concrete slab. So the capacity which you expect should be on a lower side. So probably you can decrease the load acting on single anchor by adding more number of fixings and so on. The main thing is to use the right drill bit in AAC block. You should never use a hammer drill bit or hammer drilling method in AAC block. Go for a rotary drilling, which is less impactful, which is less damaging for the AAC block, which is very important. Also, uh, choose the right type of anchors. Like, there are very limited number of anchors which can work in AAC block. We can definitely send you the list of products which work in AAC block. There are chemical anchors, mechanical anchors specifically designed for AAC block. We can send you all the details after the end of the presentation. What is the minimum edge distance need to be considered? Suppose if there is any anchor nearby from other subcontractors. See, for any anchor, if you want to be free from other anchors, you have to have an edge distance of 1.5 times the embedment depth. If you are less than this, then you have a hindrance. You have an overlap of concrete area between this anchor and the other anchor in tension. So if you don't want, you have to be independent, then you have to maintain 1.5 times the embedment depth. John, can I get a presentation file after this webinar? Yes, we would send you the presentation after the webinar. Sure. Abdul Salam Johar, can I get the presentation? Sure, Mr. Abdul Salam. We would get send you the presentation. Munishwar Sharma, please explain about grades of anchors. Very good question, Mr. Munishwar. It's a shame that I didn't include this in this presentation. But normally, the grades of concrete anchors available are 5.8 grade steel, equivalent of 5.8 grade steel, because anchors are normally cold formed. Then you have A4, we have hot dip galvanized anchors, and we have high corrosion resistance anchors. So normally, if you have dry interior conditions, we go with galvanized anchors. If you have external environment conditions, then you go with hot dip galvanized anchors for limited period of time. If you have permanent external condition, we recommend A4 stainless steel anchors. If you have very aggressive conditions like under seawater or inside a swimming pool, then you have to go with a superior grade of steel known as high corrosion steel, which is very high quality, high grade stainless steel. What is alpha in the shear load steel failure equation? By Mr. Hani. Very good observation, Mr. Hani. I'm happy that you noticed all the factors in the formula. Alpha is denotes degree of restraint. So basically, if the base plate is acting like a the anchor is acting like a pinned connection for the base plate, that the base plate can rotate, then it is alpha is 1. But if the base plate, the anchors are holding it as a rigid fixed system, then the degree of restraint is 2. So basically, there are only 2 alpha values, 1 or 2. So it depends on if you have one anchor fixing a base plate, then most likely your alpha would be 1. If you have 4 anchors in a base plate, mostly the alpha would be 2. If you have any further questions on alpha value, you can directly send me an email on this email address, and I can send you all the clarifications. Now we are at the end of the presentation, but I still have a lot of questions, and I'm really looking forward to answering each of these questions. So please bear with me. I would definitely answer these questions first thing after I finish the webinar, and you would personally receive copies of all the answers to your questions to everyone who attended the webinar. So last but not least, please make it a point to go to the poll option and rate this webinar. You can be as brutal as you want. You can say what is the things, rate the things which needs improvement as low, and rate the things which you liked as high. So please, I request you all go to the poll screen and rate the webinar. You can still continue posting questions till the end of the session, and we would answer all your questions. Okay, thank you very much, guys, for taking time for the poll. Great. Yes, Engineer Lovely, you can download the video after the webinar. We would send you a link also. So you would also, when you end the webinar, you would be having a command to download the video. So this is also an option. Yes, direct fastening also we would try our best to incorporate in our upcoming webinars. And I am mentioning my email address. If you require any further clarification on any of these topics which we discussed today, please you can directly shoot an email to me and I'll be happy to assist you. Thank you for the feedback, John. Thank you, Abdul Hafiz. Thank you, Abdul Rahman. We are planning a lot more webinars in coming days. Please be an active participant. Please support our webinars, and please let us know if you have any specific topics which need to be included, like John just mentioned. All the participants, we would send you a certificate of participation. Mr. Omar, which software? Do you mean the Fisher Experience software? Okay, we have not included this in this webinar because of time limitation. We are planning a different webinar only for the software, where we would show you all the options, all the latest updates, the new cool features which we have added, and so on. So please bear with us till you receive an invitation from us for the software. It is under the pipeline, and we would definitely inform you once it is planned. Okay, now I would introduce something really new what we have added. It is called the Fisher Professional app. One second. Right. Now, you have the download link mentioned in the chat window. Fisher Professional app is our initiative to reach our customers in the most convenient way. So it is an app available in App Store or Google's Play Store. So in this app, you would get all detailed information about every product which Fisher has. You can see our online product catalogs. You can download it. You can download the ETA approvals. You can see the MSDS safety manuals and so on. You also have a very important intuitive tool called Digital Product Advisor. You can enter your parameters and the product advisor would select the right fixing for you. Let's say if you have hollow block, it will tell you options of fixings which you can use in hollow block. You can also have an option. Let's say you are in Saudi Arabia and you want to find out your local dealer nearby. The local dealer search will track your location and advise who is the local dealer near you. There is also barcode scanner app in this software. If you are on a construction site and you see a Fisher box delivered to you, you can take the barcode scanner, scan the Fisher box barcode, and it will tell you all information. Let's say you are installing a mechanical anchor. What is the tightening torque required? What is the embedment depth? What shall be the drill bit used? Everything would be advised using this tool. So it's a very innovative tool to reach as much customers as possible and to share all the knowledge which we have in a mobile platform. You would also have Fisher News, blogs on technical articles which we publish, and so on. So it is our initiative to share our knowledge, share our product information to as much customers as possible. Also, if you require any information regarding Fisher products, our services, our webinars, please make it a point to visit fisher.ae, our web page, and register yourself. Also, follow us on Facebook, Twitter, Instagram, LinkedIn, and Google Plus to come to know about latest articles about construction industry, about latest innovations in fixing systems, new products we have launched, write-ups, and so on. So thank you very much for participating in this webinar. I hope it was informative and useful. Please contact me if you have any clarification. Also, looking forward to having the same enthusiasm in our next webinar. Looking forward to seeing you for our next webinar. Uh, Keep following us in all these platforms to come to know about all the updates of our upcoming webinars. Thank you very much for attending and have a nice day. Have a great year ahead of you. Thank you.